So under history and evolution of quality control and management, I am going to discuss the subtopic, that is evolution of quality, 4 main stages: inspection, quality control, quality assurance and CWQM, and the implications in production processes. So I've already mentioned that that when we consider evolution of quality, we refer to essentially the evolution of quality principles and management style over the years, since maybe 4,000 to 5,000 years. So many types of quality control and improvement techniques were first used in ancient times. This point to be noted. 4,000 years ago, the Egyptians measured the rocks used in their pyramids. So this is a quality exercise. Greeks and Romans measured buildings and aqueducts to ensure they conform to requirements. There are several examples. In fact, I want to highlight those examples. Craft guilds in Renaissance Europe used to specify, measure and control the quality of paintings, sculptures and architecture. So unless you start measuring those quality features or quality characteristics, how do you assess the level of quality? To assure uniformity in quality of products, guild students, I have already mentioned about the craft guilds. So the guild students used to go through exhaustive apprenticeship and other training programs overseen by accomplished masters. Exactly the same thing even today we have been doing at different organizations. Now, as I have already mentioned, we have gone through 4 stages in the modern quality. First one, inspection. Second one is the quality control. Third one is the quality assurance. And the fourth one is the company-wide quality management, CWQM. It is also referred to as total quality or total quality control or total quality management. So many authors, many practitioners, they prefer different names, but the concept wise they are all same. Okay, so what is inspection? The concept of quality as a formal discipline was introduced in industries for the first time during 1920s. The first quality groups were inspection departments. During production, inspectors to measure products against specifications. Inspection departments were not independent, as the inspectors usually used to report to the manufacturing department whose efforts they were inspecting. That means essentially, the workers, they never used to have independent authority to assess the quality. They used to be treated as only the producer. They used to produce, and once it is produced, obviously the inspectors, they used to join in and they will ascertain whether the quality specifications are conformed with or not. These present a conflict of interest. Obviously there are 2 groups, the workers, they are producing, and another group, okay, so they are inspecting its quality. If the inspection department rejected a batch of non-conforming products and the manufacturing department wanted to push this batch of products out the factory regardless of quality, the manufacturing department always got its way. That means it's like the philosophy behind this inspection based quality has been that the production at any cost. The basic production philosophy was essentially based on production at any cost instead of quality is job number 1 principle. Okay, so even these days you will find many organizations in India and several other countries, you will find they go by this logic. Product quality may only improve slowly or may not improve at all if inspection is the only means of quality maintenance and control. Now this is a question you please mark it, and the reasons behind. That means many a time you should know that what are the specific reasons. So can you highlight some specific reasons that whenever you find that there is an inspection department, immediately you may conclude that the less importance is given to quality improvement. Is it okay? So there are some inherent limitations in this approach, inspection-based quality control, as far as quality improvement is concerned. Now, when in 1940s, now what has happened that these inspection groups evolved into quality control departments. That means the first time we see that the organization is creating a separate department called quality control. The start of World War II required that military products be defect free. The product quality was crucial in winning the war and could only be ensured if the inspection department could control production process. So everyone agrees to this point. So responsibility for quality was transferred to an independent QC department, which was now considered the guardian of quality. So the first time, where the organization structure, in the organization structure, you get a department called quality control. The quality control department was now separated from manufacturing to give its autonomy and independence. And possibly you'll find wherever you find a quality control department, the organization structure is such that it has been given independent authority and power. Okay, right. Now, during this phase of development, from early 40s it started, many organizations introduced the concept of statistical quality control. So this particular the topic we'll discuss in detail, and SQC is one of the the foundation topic in any course on quality design and control, and these also referred to as the statistical process control. Control charting based on SQC or SPC concepts were proposed and implemented by Walter A. Shewhart in 1920s. So many of these control charts are named after him, and he is one of the pioneers who introduced the concept of say the control charting and the quality control or statistical quality control even in 1920s. A host of other tools and techniques, notably in the areas of process capability analysis and acceptance sampling for components and products, were also made popular and worthwhile to pursue for quality control. Subsequently, the persons like Dodge, Romig, they contributed a lot in the area of acceptance sampling, in the area of the process capability. So they are considered to be the pioneers, and I always insist that you should refer to the standards developed by them. You should refer to the textbooks written by them. Okay, so you'll get a total idea about that what is to be done, what is to be what is to be learned in the field of quality. Okay, so now in the 60s onwards, the quality control subsequently evolved into quality assurance. That means here is a system, I produce 100 consecutive items and I don't need to inspect. I don't need to check and each every item. I am sure that 100 consecutive items I produce, they are all of good quality. There will be not a single defective, but beyond 100 units I do not know. So that is my level of quality assurance. So any company you visit, any manufacturing systems you look at, you must get an idea about this quality assurance. In some other organizations, in another plant, you may find that they're saying, sir, we have achieved the next level of quality assurance, 1000 consecutive with this machinery, with these facilities. We have made the settings in such a way and we are controlling them in such a way that 1000 consecutive units are all will be conforming to the specifications of quality, and hence you don't need to inspect, you don't need to quality control. So that is my level of quality assurance. So there are such measures available, level of quality assurance. Now this quality assurance department focusing on, in specific terms, assuring both process and product quality through executing operational and quality audits. As I have already told you, that to ensure quality assurance, what is important is there must be perfect match between the product quality systems and product and process quality systems. So there has to be quality audits, importing skills enhancement training programs for operators, performing technical analysis, this is the must, this is the backup, and identifying operational areas for quality improvement. So many well-known organizations, so they are engaged in this sort of activities as far as their effort for quality improvement is concerned. So the QC department does exist in many organizations where QA has not yet evolved. So this is a situation, in particularly in our country you will find that we have a quality control part. Up to quality control part, most of the organizations they have reached, but still we have to go a long way to reach the quality assurance stage for many organizations. So QA means you are 100% sure that the production system, say a machine, produces a set of consecutive parts or components conforming to their specifications. So the assurance is 100%. So depending on how many such consecutive parts or components a machine is able to produce, the level of QA is measured, as I have been telling you. To achieve this condition, the settings of the process parameters, raw material quality and measurement systems are to be controlled and maintained at the highest level. So in this context, I should highlight one particular point, that is quality is as good as the measuring instrument. So now we move to, say, from 60s onwards, late 60s onwards, many companies they started talking about company-wide quality management. That means the quality is not only the responsibility of just one production department, it is the responsibility of all the departments of an organization. So company-wide quality management is also called total quality management or total quality control or total quality. For implementing total quality concept in an organization, its chief executive officer often leads the quality management function. So this is important. And as the quality message permeates at all level of organization and all hierarchies, all levels of the hierarchy, more people become involved and slowly a quality ethic and culture develops. So it's a slow but the definite process. The focus of the total quality program is company-wide, customer-oriented and competitively driven. So this is an important point. You please look into these aspects company-wide. So that is your responsibility. Quality no longer resides in one department. It is a company-wide issue essential to the organization's survival. So to produce a quality product or deliver a quality service requires the attention and commitment of everyone in the organization. That means it's the individual effort to be guaranteed. It is the responsibility of the person doing the work, whether it is the security guard controlling arrival of persons or transport, the manager supervising employees, the operator working on the machine, or the person delivering flowers. That means whatever may be your job, against that job you must be able to define its quality standards. So the top management usually defines a realistic policy, line management establishes the operational goals and objectives, engineers design attractive, reliable and functional products, and operators produce defect-free products in the total quality management systems. So this particular, the points I advise all of you to look into, and then only get an idea about what is actually the total quality management systems. So another important aspect of TQM needs to be emphasized, that is the customer orientation any TQM program. So that is one of the the pillars, one of the focused areas. So this is essential in any TQM program because the customer's needs change and the organizations must adapt to changing needs. That means constantly you have to look into the new standards and the new customer the requirements. Designing aesthetics products, producing defect-free products and delivering products on time at a profit are some of the issues to be considered in adapting to this new philosophy. So like say you are running an organization, so obviously you must look into one aspect, that is quality at what cost. That is very, very important. And what is the ideal relationship at this point in time? Is it okay? So it's a very complex issue, and wherever you try to quantify these issues, you must be able to collect data on this. So now as a student of quality, you should be aware of what is the difference between the inspection and preference-based quality control systems. Is it okay? Always you will confront these two types of systems. Okay. So many organizations, when you visit, you start taking up some quality related projects. Obviously, you will be confronted with a systems called inspection based quality control systems, and all efforts should be directed towards making it as far as practicable a prevention based quality control systems. So the traditional method of quality control is inspection based. Certain points I am going to highlight. The inputs are of 5 types: machine, man, operator, material, methods. Each is a potential cause of dispersion or the variation of dimensions of quality characteristics. I have already mentioned that an exercise on quality is essentially an exercise on variability and consistency. Fabrication or assembly operations process inputs by adding value to the product in each operational stage. So this is a typical system. It is referred to as the inspection based quality control. So you have 5 types of inputs. Okay, this is a generic presentation. Now the process could be 1 step or 100 steps, okay, depending on the process plan you have for the product and the manufacturing systems which you have. So it's a value adding activity. Is it okay? Because at each stage for the manufactured product, you change the shape and size of the product. So these are value adding activities. But then the output is, you get the output, and then the output is given to the inspection department, and inspection department, they decide whether you are going to accept this output or not. And if you accept it, that means they're conforming to the specifications, then those the outputs or those proportion of the output will be sent to the customers. Then obviously certain proportion may be scrapped, and the other proportion may be say 5% or 10% or certain numbers, they may be reworked. So there are 3 types of outcomes. One is acceptable, second one is the scrap, and the third one is the rework. Now obviously the inspection is a cost adding activity, and what we say that why don't you do away with the inspection? So that is the challenge you accept. That means if you want to act as a quality expert, that means the first objective should be that I will move from say inspection to quality control. And while you move from inspection to quality control, the first thing you should look into, that is, can you do away with the inspection, because inspection is a cost adding activity. So what are the features referred to as the detection based? Obviously means so many units you are producing, it is quite natural that some of these units will be defect. And so I have already mentioned the production at any cost, that is the philosophy. That means don't concentrate on quality, it will come because we have engaged the inspectors. So first you produce, then you will see, and if the defective comes, we will be very prompt enough to detect them and remove them. So that sort of systems we have. So in order to achieve these objectives, the quality control must be based on a philosophy which believes in the prevention of the occurrence of defects or non-conformance in the process itself. So what is this philosophy then? That means this how long you can continue the inspection based quality control. So obviously you will be producing defects and it becomes a the way of life. Okay, so you are detecting it, fine, but can you not prevent the occurrence of such defects or defective items? So when you do that, we move from say inspection based quality control to prevention based quality control. So here the inputs are same. Process may be 1 step or 100 steps, and the process means absolutely value adding activity, and unit by unit you check. That sort of system must be given to you, unit by unit. In many world renowned organizations, these systems already they have created, in fact. So now here the human labor or the worker, so each and every unit is inspected, and if he finds that one particular unit is defective or say non-conforming, he has to take some corrective measures immediately. Is it okay? So you go one by one, and each and every unit you check, and if you find that this unit is acceptable, then only you will go to the next stage. Okay, so the next stage or at the customer's level you send it. So adjustment is to be done, and the person who is producing the component, he will be given the responsibility, he must be given the authority for ensuring quality. That means he must be able to say use the gauges or use the instruments, is it okay, measuring instruments, so that he certifies that okay, this is this particular dimension, this particular quality characteristics of the given part conforming to the specifications. So there is no inspections over here, and whatever you produce which you send to the next stage, these are all acceptable units you are sending it. So what are the critical features, say the main important highlights of this particular system? First one is, in the prevention based quality control, the inputs are the same. That means you don't need to bring in different kinds of inputs. So that is sure. That means you don't need to change. Second thing is, in the prevention mode, the process is controlled. Is it okay? So that has to be done. That means each way which. So the important difference between inspection and prevention modes is that during processing of parts or the components of raw materials, the operator continually measures the quality of these parts and components or raw materials, adjust the process if dimensions deviate from the calculated limits. That means, in many cases we find that the operator is expert. He knows what is go or no go gauge in many a time for mass production purposes. So we design go no go gauges, okay, plus different types of gauges he may use or different kinds of measuring instruments. So obviously the idea is the person who can run the machine, who can how to create the perfect process settings. So it's become easier for him or her to use the measuring instruments to ascertain the quality of each and every component which he or she produces. Thus the operator is preventing defects from occurring by controlling the output of the operation. The objective is to send defect-free products to the customers. So in the prevention-based quality control, the number of cost-adding elements is expected to be very less. The product as well as the production cost remains reasonably low because the cost-adding activities are less. There is hardly any cost-adding activities, and hence it is most likely that a quality product can be developed with affordable and competitive price in the market. So as I have been telling you that the quality must be defined with respect to the price. So here, if your production system is very expensive, even if the specifications are acceptable, but you may not be able to produce those specifications or the quality at an affordable cost. So your product may not be competitive. So ultimately you cannot hold on the quality levels. So in today's context, when you face a lot of competitions, because there is hardly any monopoly in the market for your product. So the monopoly market is not there. So for most of the products, so what you must do, that means the cost to be reduced, and you have no other alternative but to go for prevention-based quality control. However, one basic precondition for its success is to have a workforce who can handle not only the machines but also can operate several kinds of inspection and measuring instrument as required and make appropriate decisions. Okay, so what is this implication? Implication is in the products and the processes, quality of products and processes. If you adopt this philosophy, prevention-based quality control, various kinds of tools and techniques are to be used at each of the 4 phases. You have no other alternative. That means very soon you will come to know what are the SPC related tools and techniques. So those tools you have to use, and then only you will feel comfortable in creating a system which is prevention-based quality control. A typical manufacturing system producing a product may have a number of interdependent manufacturing stages. In order to maintain and control quality of the products and processes at the manufacturing stages, the quality of all the system components such as work holding devices, this is very, very important, jigs and fixtures, cutting tools, raw materials, material handling systems, setup, etc., and their settings are to be ensured. Is it okay? Then the quality of a product determines the cost of the total manufacturing systems. So if the quality level is poor, it might mean that the cost of the manufacturing system also is very, very high. So what is important is that while you go for say this one, like say this one, the prevention based quality control, what is important is that the process details must be known, and in many a time, the process plan or the process planning components, is it okay, you must be able to create. And in the process planning component, what you have basically, that means any product you produce, so there the way you create the process plan, or the process plan ultimately determines the quality level, and it's a total document where you find that the process plan is having the details of all the operations, their settings, the kind of machine tools you use, kinds of jigs and fixtures you use, kinds of setup you do. Is it okay? And ultimately you need to control production related variables also. And now in the prevention based quality control, the entire the responsibility, in many cases there are many instances, are given to the workers. Now today what has happened, like say we are moving from this traditional say the manufacturing system to say CNC based systems or DNC based system, NC based systems, and there you will find that we get the qualified workers. Gone are those days when whenever you look at the workers, we used to assume that he is having only the skills but not the knowledge. But today we will find that even many sorts of automated control devices, automated machines, the workers they feel comfortable in handling. So prevention based quality control, the many kinds of tools and techniques we will learn later on, and you will find that with this prevention based quality control tools and techniques, we will be able to improve the quality of any product or any process. So we have essentially the three stages in prevention based quality control. First thing is you have to create a system called quality planning. So you have to document the process of creating quality. That is the first stage, and then you go for the quality control at a particular say work center, or at a particular profit center, or at a particular machine or the facilities. And once you achieve quality control, then at the third stage we go for quality improvement phase. That means suppose for the quality control phase you have certain level of variability. Now when you move to quality control phase or quality improvement phase, that means that level of variability should be changed, and this variability level must be reduced. Is it okay? So ultimately whatever, there are two kinds of tools we will be focusing on. One set of tools that are related to quality control, and another set of the tools we will be using for quality improvement. Is it okay? But our main focus is to what extent you can prevent the occurrence of defects and defectives in our exercise. Now here normally we use two terms, one is defect, another one is a defective. Now whenever you say the defect, that means we say that related to a particular quality characteristics, whereas whenever we say it's defective, that means we refer to the entire product, mainly its functional value. This is one. Now these are the terms normally any user or the non-technical person they use. But as a technical person, as an engineer, we use two other terms. One is non-conforming and the other one is non-conformity. Non-conforming means the product has become defective, the car has become defective. That means even if some of the quality characteristics are very good, but it doesn't mean anything. That means the engine is down. That means you are not getting any functional value. Is it okay? So that is to be looked into. So there are many tools and techniques with which you can control the non-conforming part, and the other part is the non-conformity or the defect. That means there could be on a particular product, there could be many types of the defects or many types of quality characteristics. Against each quality characteristics, you may define its the defect, and there could be control on quality with respect to one or more such defects or such non-conformity. Okay, so these basic ideas are a must before we take up the other issues related to the quality design and control. Thank you.